Alright guys, here we go for our video for today. We're going to be talking about regular polygons and central angles. You may have heard the term regular polygon before in geometry, but basically that is a polygon that is equiangular, meaning that its angles are equal, and equilateral, meaning that it has equal sides. So notice this triangle, each of these sides is equal to the other two sides in the triangle. On this square, all the sides are going to be the same, as are all of the angles. Same with the triangle. So same with this pentagon, all these sides are the same measurement, as are all of these angles. So the angles are all the same measurement. We know that because it's got the same number of arcs on each one. And so the same with the hexagon, same number of arcs on each of these angles shows that those angles are equal. All right? And so that brings us to the idea of the central angle. So the central angle is formed if we take two consecutive radii, and radii is just the plural of radius. So if we take two consecutive radii, and what I mean by that is we go from a vertex or corner, okay, so that's this right here, to the center of the polygon. This is blue right here. So this is our vertex, this is our center. I've drawn one here. Well, the next one would either be this one over here or the one that I've already drawn for us here. The measure of the angle between these two radii is what we call the central angle, shown by the Greek symbol theta. You might remember that from when we were doing sine, cosine, and tangent. So when I'm talking about central angle, it's important to know that when I have a circle, if I were to start at a theoretical radius and sweep out, so right here I'm at 90 degrees, I've turned 90 degrees. Right here I'm at 180 degrees because I've got another 90. If I go another 90 degrees to its corner, I'm at 180 plus 90 is 270. And if I do another 90 degrees, that's going to be 360 degrees in a circle. Okay, and so you might notice that if I were to finish filling out my little angle arc, I'd also have a circle. Now, in this case, it's a very ugly circle, but you know what I mean. So what we're saying is we have 360 degrees around this shape. The central angle is one portion of it. And so how many central angles are in a regular polygon depends on the number of sides that it has. So this is a pentagon. How many central angles do you think this is going to have? All right, good. So hopefully you said that this is going to have 5 equal or congruent central angles. Okay? So 5 central angles here. Now, if I want to find the measure of a central angle, what I have to do is put a center point in the middle of my polygon. Now, if you're drawing by hand and you're not going to be using a protractor, it doesn't need to be perfectly in the center. As long as you know it is and you know how to use it, you're going to be fine. So what I'm going to do is draw a line segment connecting each vertex to the center point. And now I've created 3 central angles. Now, if I want to know what the measure of each of these angles is, I see how many I have, which looks like 3, okay? And we know that they're all equal, so if I draw an arc on each one of these, kind of gives us that circle shape, right? So, hopefully you've made the connection that that is 360 degrees. But that's 360 degrees for all of the angles combined. If I want to know what one angle is, I'm going to divide it by however many angles I have. And the amount of angles I have is the same as how many sides I have. So in the case of the triangle, that is 3. 360 degrees divided by 3 equals 120 degrees. And so that tells us that each of these angles in here is 120. And so I'm going to go back and erase this so you guys can see what I mean. and hopefully give you a little bit of a clearer picture. So if we did that perfectly, what that means is that the angle created by this radii and this radius, between those two radii, I have a 120 degree angle right there. So, sure, you're saying, well, what purpose does that serve us? Well, the cool thing about this is now I know that I can split this into two perfect right triangles, and now I know that I can figure out this angle. If I cut a 120 degree angle in half, I'm at 60 degrees. Then I can use SOHCAHTOA to find any of these missing sides. Same with Pythagorean theorem. Once I drop this altitude here, I can then find out the area of this triangle. And you might be saying to yourself, well, how does that help me in the grand scheme of things? Because I've got three of these triangles. Well, that's for you to find out. I'm going to go over one more example with you. We're going to cover the square here. And so the square is a regular pentagon, again, because we know that its angles are all right angles. So we know that these are, in fact, right angles, 90 degrees each. And so that means that the sides are also equal since it's a square. Okay? So, dealing with the square here. Now I'm going from vertex to center point. Okay, so I want you guys to try to do this without my help. So while I'm doing this, I want you to be focusing on your square and drawing your triangles created by your radii. All right? So there's 1, there's 2, 3, and 4. And hopefully you knew to draw 4 central angles. Okay? So we have 4 central angles here, and we're going to repeat the same process. The overall outside is still a circle. That's not a very good one, but we still know it's a circle, and so it's still going to have 360 degrees. Only this time, instead of dividing by 3 for the number of angles and sides, I'm going to divide by 4. Now, hopefully you already know what each of these angles measures, and since there are 4 of them, it's going to be the same here. But 360 degrees divided by 4 is, in fact, 90. So if I have a 90 degree angle up here, and I have a 90 degree angle that I cut in half here, making it 45, and also making this one 45, we know that we have 180 degrees in the triangle, so 90, 45, and 45 is 180. Now, again, how does this help you? Well, if I don't know how to find the area of the square, but I do know how to find the area of one of these triangles, I can figure out how many triangles I use to make up the whole square and try to find the area from there. I'm going to let you guys do the pentagon on your own, and then I'll show the example, and the same will be for the hexagon after that. So get to work. Alright, so hopefully you were able to get through this, and if you were not, hopefully you asked me some questions. But to get started on finding the measurement of the central angle for the pentagon, which is a 5-sided shape, and we know that it also has 5 angles, and that since it's a regular pentagon, all the sides are equal. And so if I'm trying to figure out what each of these angles is, same process, 360 degrees for the circle, divide it out by 5, and so 360 divided by 5, we've got 60, 70, 72 degrees. And so what that means is that each one of these angles is 72 degrees all the way around that center point. 72, 72, 72, 72, 72. We know that because it's called a regular polygon, that all the angles are going to be the same, including the central angles, and that helps us find these other angles. So right down here, if I wanted to know what this second angle was, I could say, well, I have 180 minus the 72 that I know is going to give me that 108 remaining. And then I say, yeah, that's that 108, but I have 2 equal angles splitting this 108. And so I can say 108 degrees divided by 2, which gives me 54 degrees. And so I know that this angle down here is 54 degrees. This angle right here is 54 degrees. And now I can use SOHCAHTOA if I drop an altitude there. Or I could use Pythagorean theorem if I knew two of the sides, okay? Or even if I use one of the sides and then SOHCAHTOA to get the other side and then calculate the missing one. So again, we're seeing a lot of things coming back to the triangle, and that's why we spent so much time really hammering down Pythagorean theorem and the trig functions. So now it's your turn to work with the hexagon, the six-sided figure, and I'm going to let you to that. All right, so hopefully you started off finding out your central angle for the hexagon, the six-sided figure, by drawing radii from the vertex to the center point. And so now I've got all 6 of my radii drawn. Looks kind of cool. And so we notice, again, it's broken it up into how many triangles? 6. 6 equal triangles. Okay. So I want to know what my central angle is. I take that 360 that I know from the circle. I divide it by the number of angles that I have going around that center point, which is 6. Same number as the sides of the polygon. And so 360 degrees divided by 6 gets us 60 degrees. All right. So we know that this angle around this center point, all of them are going to be 60 degrees. And that allows us to figure out what each remaining triangle is as well. So if you do 180 minus 60, you see that's 120. Don't forget our degree symbols, 120 degrees. And then because I have 2 of them, I'm going to take 120 degrees, divide it by 2, and we'll get 60 degrees. Interesting. That's given us 60 degrees here, and 60 degrees here, and this is 60 degrees here. So we have a very special kind of triangle that we talked about yesterday, and hopefully you will be able to make that connection. If you have any questions about anything that we covered in this video, or where we're going with the central angle and the regular polygons, please raise your hand and let me know. But really the key for you guys is to see that we can form shapes out of other ones and see that, hey, I can draw a triangle out of here, and that can give me some information I can use to figure out the rest of the polygon. All right, I'm not going to tell you too much. I want you guys really to work hard on this next upcoming problem about the pentagon corral. And please feel free to work with others. Feel free to work by yourself. Feel free to ask me questions. But really, I want you to try to figure as much of this out on your own or with a classmate as you possibly can. All right, so work hard, get to work, and let me know if you have any issues or questions that you want to ask.